Hello everyone, I'm going to discuss about today's session based on precision rectifier, and this is very much useful for any kind of exam, especially for GATE exams, even our semester exams. So the topic name is precision rectifiers. Precision rectifiers. So why we would use precision rectifier? What is the basic advantage of this precision rectifier over normal rectifiers? The reason behind is that in the normal rectifier circuits, this rectifier circuit can't rectify the input voltage levels those are having less than 0.7 volt or 700 millivolt, less than 700 millivolt or 0.7 volt, because this is the cut-in voltage for a conventional diode. So below to this volt, this diode cannot rectify directly. So for that we are going to use precision rectifier. Over there we are using operational amplifier, and along with we are using diodes. Not only we are using only the diodes, here we have some operational amplifiers. Based on that we are going to use these diodes. So combining these two we are making the precision rectifiers. So I will not waste our time, I will go directly to the rectifier circuit. So as we know, we have two rectifiers, half wave rectifiers and full wave rectifiers. So I will first discuss with half wave rectifier circuit. So let us draw the circuit diagram first to make you understand. So half wave rectifier, half wave precision rectifier, the circuit diagram is, as I mentioned, we will use operational amplifier. Okay, so this is minus, this is plus, inverting terminal, this is non-inverting terminal. So suppose this non-inverting terminal is grounded, and in the non-inverting terminal we are going to use our input signals. So this is, as we always write, this is Ri, input resistance, and suppose here we are going to use the input voltage, and here must be some diode connections here. So we are arranging a diode, this one more diode here, this one diode here, and RF is connected here. This is RF, not directly to outputs, and here also we are using one more diode here, there. So please students carefully see the diode. Suppose this is D1, this is D2, so their orientation, this is P, this is N, this is P type, this is N type, this is P type, this is N type, and this is RF. So this is V0, and the voltage across this point we are writing as VOA. Now we have to understand when this diode D1 is on and when the diode D2 is off. As I mentioned every time, when the diode, this, suppose this is a diode, this is P type, this is N type, if this gets its positive potential and this side getting negative potential, that is called the forward bias. So then in this time this diode is on and it gives you 0.7 volt across this diode. If it is minus and this is plus, so then it's called reverse bias, and it is now open circuit conditions, or you can say that the input impedance is is infinity. So this way, that means this is off state, this is off, this is on. So based on that we will discuss. So I will draw the waveform, so just make it clear. So what I mentioned is that when the PN junction diode is forward bias, this is on state, you just write forward bias is on state, reverse bias off state. You remember these things. So now let us start the operation. When we are giving the positive input here, positive, that means like this, we are giving this signal. So this is time, this is V in or Vi. So this positive, we are thinking about the positive terminal. Then what will happen? If we give the positive here, the output will be negative. So this point will be negative. Why? Because inverting amplifiers. So if this positive, then output will be negative. Then what will happen? This diode getting forward bias, because this N type getting negative, this N is getting negative. So that means this D1 is off. Here D1 is on. But what should be the D2? Because here negative and this is positive. So negative. So D2 is off. So D2 is off here. Now what will be the output condition? That we have to check. Now as this is on, D1 is on, so that means this path almost short circuited. So this is short circuited. That means the current will flow by this path. So RF is, no current will flow through the RF. So that means V0 would be 0. So at the output we don't get any outputs, because this is open circuit, D2 is open, there is no physical connection this output in these two terminals from here and here, because this is open circuit, this is off, so this is open circuit, and this is on, so this is short circuit. So the path is like something like that. So RF is removed from the feedback path, so the output is 0 here. So here we don't get any output, this is 0 only. Now what will happen for the reverse case? When this is negative, then definitely this should be positive. So as it is positive, so this is negative getting positive. Okay, so that means this is reverse bias. Now reverse bias means this is off. So D1 is off. So in this case D1 is off and D2 is on. Why D2 is on? Because this is positive. So this is positive and this is P. So P getting positive, so forward bias. So now that means this is open circuit, this is open, so there is no existence of diode. So this is open circuit, means we can say that there is no existence of diode here, because it is now off. So this is open circuit. It's like something like that. I am writing the equivalent circuit. So I am writing the equivalent circuit. So like this the connection, and this is short circuit. So we may say that this is short circuit. Short circuit means almost short circuit. Okay, but here existence is means we can say the very small resistance 0.7 volt like this. But anyway, now the circuit is like this. So that means now we will get the output, because this RF is now connected. So R1 RF is just like a normal inverting amplifiers. So now we will get the output. Okay, so at the output we will having the output signal, but this is negative, this is output is positive. In the input we are giving negative, output is positive. So definitely we will get this, because the output is positive because of the inverting comparator. So like this again we don't have, we have. So only for negative halves we are getting the outputs, but for positives we are getting 0. For positives we are getting 0. So this is the basic operation principle of half wave precision rectifier. So my dear students, just go through it, and if you have any doubt, please comment on the comment sections, and do subscribe and like these videos. Thank you so much for your kind attention and for your constant support. So in near future we will come with new videos, and the immediate next video we will come up with full wave rectifier circuits. Okay, the precision full wave rectifier circuits. So till then, stay tuned. Bye bye.